In this video, I will show you how to evaluate trig expressions such as these using the sum and difference identities. Now, we need to have memorized these trig values that apply to 45 degrees, 30 degrees, and 60 degrees. So I need to break this down into one of those, well, two of those special angles. However, one strategy is to convert this over to radians so that I can use the pi over 4, pi over 6, and pi over 3. And that's the strategy I'm going to use for this particular problem. So if I want to convert 195 degrees into radians, I need to multiply by pi over 180. So basically I need to reduce 195 over 180. Clearly both of these are divisible by 5. So if I divide 195 divided by 5, that's 39. And if I take 180 divided by 5, that's 36. Okay, now I can see that these are each divisible by 3. So I'm going to do that next. Okay, so that's going to be 13 pi over 12. All right, that's as far as we can go with the reducing process. So the sine of 195 is the same thing as the sine of 13 pi over 12. All right? Now 13 pi over 12 is not one of my special angles, pi over 4, pi over 6, pi over 3. I have a special technique that I use to break this up into the sum or difference of special angles. And that is to subtract pi over 4 and see what you get. So 13 pi over 12 minus pi over 4. Okay, let's see what that is. Well, for like denominators, I will have to multiply by 3. So 13 pi minus 3 pi, well that's 10 pi. So now I have 10 pi over 12. But this equation is the same as having the equation 13 pi over 12 minus pi over 4 is equal to, and this reduces down to 5 pi over 6. Pi over 6, that's a special angle. Now I'm going to add pi over 4 to both sides. So that's going to give me 13 pi over 12 is equal to pi over 4 plus 5 pi over 6. So this is what I'm going to substitute in place of 13 pi over 12. So I can rewrite the problem as the sine of pi over 4 plus 5 pi over 6. Okay, obviously I have the pi over 4, but even 5 pi over 6, what matters is that the reference angle is pi over 6. So I'm all loaded up with special angles now. All right, so let me just erase this in case I need the space. So now I'm going to use my formula, my identity for the sine of something plus something. And that goes sine, cosine, plus cosine, sine. So that means sine of pi over 4, cosine of 5 pi over 6, plus cosine of pi over 4, sine of 5 pi over 6. All right. Now we have memorized that the sine of pi over 4 is radical 2 over 2. Cosine of 5 pi over 6. Well, let's start with the reference angle pi over 6. We've memorized that the cosine of pi over 6 is radical 3 over 2. So I'm going to go ahead and put radical 3 over 2 because since the reference angle is pi over 6, then the cosine of 5 pi over 6 will either be radical 3 over 2 or negative radical 3 over 2. All that matters is the quadrant. So let's see. Here is 6 pi over 6, aka pi. So 5 pi over 6 is just going to be one reference angle less than that. So that's going to be 5 pi over 6. So 5 pi over 6 is in the second quadrant. Cosine is negative in the second quadrant because it's to the left. So keep going. Cosine of pi over 4, that is also radical 2 over 2. The sine of 5 pi over 6. Well, the sine of reference angle pi over 6 is 1/2. So it's just a matter of, is the sine function positive or negative in quadrant 2? It is positive. So we have this. So that's going to give us negative radical 6 over 4 plus radical 2 over 4. And we already have like denominators, so we can just go ahead and write negative radical 6 plus radical 2 all over 4. And that is going to be the final answer. All right, I'm going to solve number 5 using a different strategy. In degrees, the special angles are 30 degrees, 45 degrees, and 60 degrees. But I'm noticing that I can simply add 45 and 60 to make 105. So it'll be easier for me just to leave it in degrees this time. So I'm going to find the secant of 45 plus 60. Now, the secant is the reciprocal of the cosine function. So my strategy will be, first I'm going to find the cosine of 45 plus 60. And then whatever that is, I will do the reciprocal. Now, I very often forget. By the time I get to the end, I forget to do the reciprocal. So you remind me. If I get to the end and I think I'm done and I haven't turned it upside down yet, yell at the screen. Anyway, the cosine formula, the cosine of something plus something goes cosine cosine minus sine sine. So that's what I'm going to do. I'm going to do cosine 45 cosine 60 minus sine 45 sine 60. Cosine of 45 we have memorized is radical 2 over 2. Okay, cosine of 60, that is 1/2. Again, make sure you have memorized all of the values on this chart. So you should not have to look back at this chart. But I'm just doing that for instructional purposes, just in case you have not memorized the chart yet. The sine of 45 is radical 2 over 2. And the sine of 60 is radical 3 over 2. Again, that's just right off the chart. So if I multiply this out, I'm going to wind up with radical 2 over 4 minus radical 6 over 4. Okay, so in the end, that's going to be radical 2 minus radical 6 all over 4. And I almost said, and that's the final answer. But then you would have had to yell at me, like, no, Burton, this is the cosine of, what was the original angle? 105. Okay, that's the cosine. So the secant of 105 is going to equal 4 over radical 2 minus radical 6. Because you got to do the reciprocal. All right, I missed a little bit with that box. All right, there you go. All right, next let's do the tangent of pi over 12. And again, I'm going to use my technique of subtracting pi over 4 to see what I get. Multiplying by 3, so I have like denominators. That's going to give me negative 2 pi over 12. So that means pi over 12 minus pi over 4 is equal to negative pi over 6. Adding pi over 4 to both sides, I get pi over 12 is equal to pi over 4 minus pi over 6. So this is what I'm going to substitute. So I can write this as the tangent of pi over 4 minus pi over 6. All right, let me just erase this stuff right here in case I need the space. Okay, now how do I do the tangent of something minus something? So it'll be tangent minus tangent over 1 plus tangent tangent. So I'm going to do tangent of pi over 4 minus tangent of pi over 6 over 1 plus tangent pi over 4 tangent pi over 6. Now, all of these values are on my chart, all right? Tangent of pi over 4 is 1, and tangent of pi over 6 is radical 3 over 3. Okay, so tangent of pi over 4, that's 1, minus tangent of pi over 6, that's radical 3 over 3. Okay, now in the denominator, I've got that 1. Since the tangent of pi over 4 is 1, but then I'm multiplying by something. 1 times something doesn't change that something. So I'm really just not going to write anything for the tangent of pi over 4 because it's a 1. Now, the tangent of pi over 6, again, was radical 3 over 3. All right, now I'm going to use the magic of the number 1 because I need to add these together. But the number 1 can be written as anything over itself except for 0. So I see I need a denominator of 3, so I'm going to write, instead of 1, I'm going to put 3 over 3. Okay, let's make a new column. So this is going to be 3 minus radical 3 over 3. Okay, that's the numerator. And this will be 3 plus radical 3 over 3. All right, notice how the denominators are the same. Boom, boom. Those are going to cancel each other out. So that's going to leave behind 3 minus radical 3 over 3 plus radical 3. And this will be the final answer. We will do something very similar for the sine of pi over 12. Yeah, so once again, we will start with pi over 12, and we will subtract pi over 4. But I will need like denominators, so I do that. Pi minus 3 pi is negative 2 pi. So I've got pi over 12 minus pi over 4 is equal to negative pi over 6. Then if I add pi over 4 to both sides, that's going to give me pi over 12 is equal to pi over 4 minus pi over 6. So this is what I'm going to use for my substitution. So I can rewrite the problem as the sine of pi over 4 minus pi over 6. All right, so let me just erase all this mess in case I need the space. So let's use that formula for the sine of something minus something. All right, there it is. Sine cosine minus cosine sine. So that's going to be the sine of pi over 4 cosine pi over 6 minus the cosine of pi over 4 sine of pi over 6. The sine of pi over 4 is radical 2 over 2. The cosine of pi over 6 is radical 3 over 2. The cosine of pi over 4 is radical 2 over 2. And the sine of pi over 6 is 1/2. So that's going to give us radical 6 over 4 minus radical 2 over 4. So that's already like denominator, so that'll be radical 6 minus radical 2 all over 4. Kabam. Okay, so here again, we have 19 pi over 12. So I am going to split that up by subtracting pi over 4. So I will need like denominator, so I will multiply by 3. 19 minus 3 is going to be 16. So that's going to be 16 pi over 12. So this equation becomes 19 pi over 12 minus pi over 4 is equal to 4 pi over 3. All right, I'm just reducing this down. So adding pi over 4 to both sides, I have 19 pi over 12 is equal to pi over 4 plus 4 pi over 3. So this is what I will use for my substitution. So the original problem can be rewritten as the cosine of pi over 4 plus 4 pi over 3. All right, I'm just going to erase all this stuff in case I need the space. All right, now let's work the formula. The cosine of something plus something. It goes cosine, cosine minus sine, sine. So we're going to have the cosine of pi over 4 times the cosine of 4 pi over 3 minus sine pi over 4 sine 4 pi over 3. The cosine of pi over 4 is radical 2 over 2. We've memorized this. Now, for the cosine of 4 pi over 3, obviously the reference angle is pi over 3. We've memorized that the cosine of pi over 3 is radical 3 over 2. That's a lie. We've memorized that the cosine of pi over 3 is 1/2. It's just a silly little mistake I almost made. But what about the cosine of 4 pi over 3? Well, that's either going to be 1/2 or negative 1/2. Those are the options. So it depends on what quadrant we're in. So here's a quick little sketch. 3 pi over 3 is right here, all right? Because obviously I'm indicating pi, so that's the same thing as 3 pi over 3. So 4 pi over 3 is just going to be 1 pi over 3 past that. So anyway, the point is that it's in the third quadrant. Cosine is negative over here in the third quadrant because it's on the left-hand side. Okay, we'll leave that diagram there for later. Sine of pi over 4 is radical 2 over 2. And sine of 4 pi over 3, well, start with the sine of pi over 3, the reference angle. That's radical 3 over 2. The only question is, will it be positive or negative here in the third quadrant? Sine is also negative in the third quadrant because sine is a y value and this is down. So this is going to leave us with negative radical 2 over 4. Now, this is going to be minus a negative. You know what, maybe I'll just write it down that way. So I have minus and negative radical 6 over 4. And you learned from like 4th grade that minus and negative is addition. So that's why this is going to wind up being radical 2 plus radical 6 over 4. Kabam. So problem number 9. Hopefully you can recognize the pattern in this matches one of our sum or difference formulas. See how this goes cosine, cosine, minus sine, sine. Can you see that among these? Here's cosine, cosine, minus sine, sine. That means it must be the cosine of something plus something. Now the two things that are going to be added, the two angles involved, are this and this. So this must be the cosine of pi over 3 plus 2 pi over 3. All right, these have like denominators, so I can go ahead and add these together very easily. This would be the cosine of 3 pi over 3. Now these 3's will cancel each other out, so that will just be the cosine of pi. And we are supposed to evaluate this to find the exact value. So I won't stop here. The cosine of pi, so here's pi right here. Cosine is an x value, so the x value here is -1. So that is the final answer. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.